Buenas tardes, good afternoon. My name is Marilé, Colón, Robles. When you hear my name, think of clouds, okay? So I'm gonna be talking about the, yes, the cloud dance, yes! Okay, we'll do it later. But I'm here also with Ashlee Autore, who is the scientist who's looking into the data. So I'm gonna give her some of my time. But here's the clouds team. You can reach out to us, and especially Ashlee if you have any further questions, and then this is possible because of a full team. But in 2017, that data that was collected, we were able to do research with the help of Dr. Brant Dotson at NASA Langley Research Center and find a correlation between cloud cover and how cool did it get with the temperature, the air temperature data. But one of the reviewers of that paper asked us, what about the different climates across the US in this case? So with this, the 2024 eclipse data, this is what we want to do. So I'm going to pass it on to Ashlee so she can talk about what she's found so far.
Thank you. All right, so we're going to start off here with just some imagery. This is a GIF of Ghost 16, the satellite covering North and South America. So as you can see, you can actually watch the eclipse happen in this imagery. So you see the shadow go across. We'll play that through again. And you can see the clouds here. So I just wanted to get a general overview of what the clouds looked like during the eclipse. So that's what we've got going on. There's the eclipse coming up through Mexico, over the United States, and out through Canada. Now, we collected observations from people all across the globe for this eclipse. Fantastic. But we focused here on cities closest to totality, just because that's where we had the most observations, and we could say that we had the best representation because these numbers of observations agreed with each other versus just sporadic, one here, one there. So on this map, this is the United States. The blue line is the path of totality of the eclipse. Each red line outside of that represents 20% decrease in totality. So those first two lines are going to be 80% totality, and then 60, 40, etc. All of those black points represent globe observation data. So that came from all of the volunteers that gave us data and showed us what they were looking at during the eclipse. The red points represent the big city that I looked at, because I was taking data from weather stations on the ground as well. So those came from big airports. So that's what those dots represent. So I'm combining all of these data points to try to get a big picture of what's going on. What is going on? How does the eclipse change the cloud coverage? Does it have any effect on it? We know it affects temperature, and we know that clouds are affected by temperature and humidity. So here we find that looking at the globe data with satellite reports, I pulled in some model data as well, other weather reports, we have some balloon sonde data from the Balloon Project, and we were looking at clouds at different levels. We have low, mid, and high. We found that most reports were showing something happening with contrails. So that's what we're starting to look at. The contrails being a high-level cloud, typically about 200 to 300 millibars, if you're familiar with the pressure in the atmosphere. And we saw that they were increasing the contrail reports, especially 1 hour after eclipse maximum. So that just gave us something more to look at and something to consider. So we are trying to look at different sources of relative humidity and temperature and pressure just to see in the high-level atmosphere what might have been going on and how the eclipse might have been affecting it. Here is some of the imagery that we received from the volunteers that sent us their pictures. So those first two are Waco, Texas, and you can see it's at the same exact location, same person standing in that field. You can see the contrails. And then those bottom three pictures are from Toledo, Ohio. Again, you can see the clouds clearly changed, right? And you can tell how the contrails might be changing as well, because I have the times down there. And so we're seeing this in various locations, that the contrails, maybe they started off non-spreading, and then they changed to spreading after the eclipse. That's what we're trying to figure out. We also have these images from EarthCam. Great website. They have cameras set up all across the globe. You can just go to their website, type in a location, and you can see what people are doing right then and there. So I grabbed these videos. We have Washington, D.C., and then Naples, Florida, both not in the path of totality, but with good globe observations, and we saw that contrails were changing at these locations. So I just wanted to give you some imagery here so you can actually see for yourself how things might have been changing on April 8th. And you can actually see in Florida where it got darker during the eclipse, before sunset. And now I'll pass it back to Marilé to say final words.
Yeah, so thank you so much. This is an ongoing research. We are working with different groups at NASA Langley Research Center, looking at the contrails reports and your observations as well. So if you have any questions more into this data, you can reach out to any of us here, Ashlee or I. Thank you so much.